Hi, I wanted to take just a moment, won't be very long, to show you how the periodic table and the electron configuration charts that you now learn how to use are related, how you can connect them, and how you can use the periodic table to make your life a little bit easier when you have to write electron configurations. So I'm just going to make up a configuration and show you how it works. So let's take something like, I don't know, let's say phosphorus. Phosphorus is right here. It has 15 electrons, and if I was going to write the configuration, I would use this configuration chart, and I would have to get 15, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different lines on there to write the configuration. And then this is just the work, of course. The configuration is 1s2, 2s2, 2p6, 3s2, 3p3. So there's the configuration for phosphorus with 15 electrons. Now, when you add more and more electrons, obviously this gets to be a longer and longer process as you're adding lines. You know, it's a lot of lines if you're going all the way up, and it just takes a lot of time. There's a shortcut. There's a shortcut to make your life a little bit easier. You don't have to use it, so I'll preface it by saying if you like adding all the lines and you want to count up that way, you can always do that, and you can always get it right if you do it that way. But I want to show you a shortcut that might make your life a little bit easier, and I'm just going to erase what I have written here and scroll back up to the periodic table. And I'm going to be scrolling back and forth, so apologies if that makes you like nauseous or something, I don't know. So let's take a look. You've got, on the first line of this, you've got 1s, and you can fit 2 electrons in there, right? Because each orbital, this is an orbital, can hold 2 electrons. So 1, 2, check it out. 1s, 1, oh, sorry, 1s1, 1s2, okay? Then I'm at the end of this row, the first row. So I go to the next section. Down here, I've got 2s2, so I put 2 electrons can fit in there. So up here, 2s2 is these 2, okay? And now I'm over on this side where the boron is, and I'm going to, how many spots can I fit in there? Well, the 2p can fit 2 electrons per, so 1, 2, 3, 4, 5, 6 total. So I go back up here and guess it. Guess what? Check it out. 1, 2, 3, 4, 5, 6 total. Now I'm at the end of this row where neon is, so I make a new line, just like I do here. And check it out. I've got 3s. I can fit 2 electrons in there. Back up top. 3s, 2 electrons. And then keep going. I think you get the idea, though. 3p again can hold 6 electrons. And guess what? The 6 electrons, you can fit them right here. 3, 4, 5, and 6. Okay? So in this way, the periodic table is sort of connected to how you have the electron configuration chart. Now let me draw some lines, more lines. Erase these guys. There we go. So on the periodic table, actually it's sort of divided into sections. So let me just get like a fun highlighter color here. All of these, this section right here, all of these are the S block. They always end in S. That's like the S section corresponds to S's down here, like this one or this one. This section here on the right-hand side, which is going to need its own fun color, obviously, these always end in P, not helium, so let me abort. These right there always end in P. So that section is the P section, and they will have configurations that end somewhere in the P's. When I'm talking about P's, I'm talking about this one or this one. Oh, there we go. And then this middle section needs its own fun color. All of these end in D. This is the D block there. That's terrible. Do better. There we go. Still not great, but what are you gonna do? Okay, so that's how it corresponds, and also, not only that, but the row that we're talking about here, that corresponds to the number down here, the 1, 2, 2, and 3. So like this is 1, and then 2, 3, and 4, et cetera, et cetera. And so in this way, you can play a sort of battleship. I don't know if you guys ever played Battleship, but I'm 100 years old, so I played it before, where you can check if I said, now, what's the configuration for phosphorus? What was the first one we started with? Phosphorus is right there. If I said what's the configuration, you can say, oh, it's in the P section, right? And it's 1, 2, 3 rows down. And so it is also 1, 2, 3 over in the P section. So you can say it ends in 3P3. Oopsies. This 3 is the number of rows down. Oh my gosh, why would this happen to me? Abort. Sorry, you're forced to watch this. Just an old person dealing with technology in the worst way. So over here, 3P3. The first 3 is the number of rows down it is. And then the last 3 is the number of rows over it is, and the P is the section that it's in. And so back in the chart then, you can just go, oh, I have to go up to 3P3. So I go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. And then you can write the configuration because now you have the chart all filled up there. And you can say, oh, it's 1s2, 2s2, 2p6, 3s2, 3p3. So the chart is connected to the periodic table in that way, where each spot corresponds to, and each row corresponds to an energy level, and each section, the yellow, green, and the orange, corresponds to like what it's going to end in. Let me erase this entire thing. Maybe there's an easier way to do that too. That's not erasing, but I'm too old to figure out these complexities. So let me just erase it this way, and also this way. And the only thing you have to remember is that when you're in the D section here, these guys are in the D section. When you're in that section, the number just drops down. So if I was going to do, let's say, vanadium, which is right here, if I was going to do vanadium, well then, to write its configuration, I say it's in the 1, 2, 3, 4th row down, and it is 1, 2, 3 over in the D section. And so when I write this, it's not going to be 4D3, it's going to be 3D3. That's just the way that the chart works, right? If you're looking up here, it goes 3D first and then 4D. And so that's just a thing you need to remember, that the 4th row is the 3 for the Ds. Anyway, so it ends in 3D3, and now you can just fill up all the way to 3D3. I mean, yeah, if you don't like to do it that way, it's just a little bit faster. You don't have to. You can say, you can count up to 23 on your own, of course, but now I know it ends in 3D3, so I'm just going to fill up everything up to 3D3. 1, 2, 3, and now I can just write out what I've written. So I know where the end of the spot is, and now I can just say, oh, it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. And that's the configuration for vanadium. Anyway, the two things are tied. They are linked together, and understanding that might make your life a little bit easier. But this has been super fun, and I hope everyone's doing well, and take care of yourselves. Bye.